I want to kick it off actually with a question to throw out to you in the audience before we dive back into our panel. Raise your hand if you think we need new technologies to tackle climate change. So that was somewhat of a trick question to make the point that whether we like it or not, we will need a whole host of new technologies and scaling current technologies to tackle climate change, build out renewable energy, and over time transition away from fossil fuels. We've convened an esteemed panel today that Kate already introduced to talk about these different technologies, what the university's new institute is leading on this front, with, of course, a particular focus on batteries. Contrary to the reality outside, it's not always windy, and we still need energy when it's not windy or sunny. So Shirley, I want to throw it to you first. Set the scene for us on energy storage in particular. Why is it so important to the energy transition, and where do we need to go from here to get it to where we need to be to sufficiently address climate change?
Thank you, Amy. So let me first say I'm deeply humbled here. We have Paul sitting next to me. When he was in the Office of Science, DOE, he funded a lot of the foundational work at Argonne about next generation batteries. And then we have a CEO from Exelon who actually put a lot of these technology into practices. So I'm really humbled to be here to share my views. So I think Senator Heidi already said very well the intermittency nature of the low carbon source energies like wind and solar represents this huge challenge that how can we stabilize the grid. And we also recognize that in the transportation sectors, energy storage already played a pivotal role in terms of displacing some fossil consumption. So I just want to paint a picture here for everyone. Imagine if you have a battery that will last for 50 years. I know it's hard for you to imagine now, but with technology innovation, imagine that. And then imagine a battery that made with no critical elements. No lithium, no copper, no cobalt, no nickel. And that's entirely possible thanks to some of the earlier work that the Department of Energy have funded. Also, imagine that your batteries, whatever materials you use in the battery, that can be recycled 99.9%, just like the lead acid batteries. So with all those technology innovations coming on our way, we project the future energy storage cost can be lowered from today's more than 10 cents to 1 to 3 cents. And that's the goal that we have promised the Department of Energy. You know, of course, the hub I led have 45 top scientists from all over the United States. We, as a team, together with about 80 students and graduate students, are working towards those goals. So the goal is really, you know, with innovation in material science and processing science and recycling science, we will be able to make energy storage technologies to the cost where each kilowatt hour you amortize is only 1 to 3 cents. So I hope a few years later you come back and check the fact. We need some time.
Wow, 50 years. I would love to not have to charge my phone for 50 years. So I will definitely keep close tabs on that. Calvin, I want to turn to you and then come back to Paul. Calvin, you're really at the intersection of where the rubber hits the road on this topic. So would love to hear from you about your perspective about how integrating battery storage onto the grid is going, and to kind of continue the conversation that Senator Heitkamp brought up in the last panel, how is AI supercharging these debates?
So first off, let me begin by saying thank you. And congratulations to the University of Chicago and all that you're doing in terms of the Institute for Climate and Sustainable Growth, because everything that you've been talking about is my world. And I say that in all seriousness. I'll give you an example. Having an earnings call this morning, and probably 80% of those calls were focused on the growth that's happening across the country in terms of artificial intelligence, data center growth. I think we heard John even say it may go 3 to 8 times the growth. And what happens so often is that we talk in terms of climate or sustainable growth. And it really has to be an and. And then you put where I, as you said, sitting at the intersection of all of this. It's about, can we deliver safe, reliable, and affordable power? Because you don't have an energy transformation if everyone isn't transitioning. You can't leave out the west side of Chicago and just ensure that downtown Chicago is taken care of, or that Hinsdale is all good. You have to focus on everyone, or the transition really never occurs. So that equitable component is key. And technology is going to play a major part in there. And not just technology for technology's sake, it has to be affordable technology. And I think that's how we get there. So I'll give you a real example. You heard of Exelon, and most of you know it as ComEd, the owner of ComEd. But we own 5 other utilities across the United States, and they all represent large urban areas, coastal regions, and rural. The energy transformation is different to each one of them. And I think someone said it earlier when they talked about you have to have the right market conditions to encourage the right incentives to get this done. What's happening in the United States is that we want a 21st century grid, but we're still playing by 19th century rules. We're still expecting to get there with what we've been doing for the last 30 to 40 years, and you won't get there. You talked about the transmission build out. It should not take 2 years to even site a transmission line. But you won't get clean energy, distributed energy resources in place until you get the transmission system built up. So that's the tension. But if you don't have institutes like this to have the conversation, it'll never happen.
That's great, and we're going to come back and unpack a bit of that in a moment. Paul, I want to turn to you. I think we've heard a couple of different perspectives from the Democratic side of the ledger here already. As some of you might have heard, we have somewhat of an important election coming up in a few days. Senator Durbin said earlier that if a certain candidate were to win, that he would want to get rid of all of this. Could you give us your perspective on some of the comments that you've heard already today, coming as somebody who did represent the Trump administration? And then in addition to that, coming back very specifically to this panel, is what do you think is the right role for government when it comes to investing in and researching and scaling energy technologies?
Yeah, so, trying to move things through Congress many times can be a challenge, but what we ran into in 2017 was trying to build consensus on what to go focus on for the country. And it turned out a giant consensus was in discovery. And we increased funding for the university system across the country, for the national labs across the country, to historic highs. And it's been hurt recently because of inflation, right? Where the support of funding for UChicago, UC Berkeley, and every other important institution because of inflation. There was a giant increase in discovery. And by the way, it wasn't just in the physical sciences. It was at NASA and going to the moon and all these other things that were going on. And so we're seeing the benefit of a lot of that early discovery. So let me give you a battery storage one, right? So when we awarded the one and only battery storage hub when it was issued, for some reason they diversified it across 2 this last time. I'm not certain I would have done that. I think I would have left it 100% at UChicago. Maybe. We were looking at the frontier. What's the future? Right? Not the past, not even the current, but what's the future, right? And so when I showed up, most of the battery storage work was in lithium ion optimization. Now, Tesla and others were doing fine work on that. That's not discovery science. We won the Nobel Prize. Our research team won the Nobel Prize that we supported for the lithium ion battery. I went to the Swedish event, and it was fun, and it was a great dinner. By definition, if you win the Nobel Prize, you've kind of succeeded at discovery. That's a good measure. And so we decided to completely shift to the future. We actually de-emphasized lithium ion at Argonne, at UChicago, and elsewhere, to the 30 plus other chemistries that could accomplish the things that Calvin was talking to, that you were talking to. Because for those of you not familiar with chemistry, there's probably more than one chemistry in the world. And one of the ones that started here, I'm on the board of Dominion, and we're building several thousand megs of storage in Virginia to manage data center and our giant 12,000 megawatt of solar that we're building. It's a huge amount. Was a series of chemistries that came out of Argonne, came out of UChicago. I'll give you just one to your exact point. So the iron air battery was helped developed at Argonne National Lab. The iron air battery is 80% cheaper than lithium ion, 80%. It is 25 times the duration. Instead of 4 hours, it's 100 hours. And the materials are iron and air. That's kind of, so we got some of the material here, and then it's iron. It literally rusts and derusts. Okay, that's the chemistry. Okay, no cobalt, no lithium, right? None of these other materials, 80% cheaper, 25 times the duration. And Argonne and UChicago were a part of that development, and now it's being deployed at the company I'm on the board of, one of the first utilities to deploy this. So some of these, I want to make sure everyone kind of sees that, right? This is many times you kind of get these kind of high-level points. Get a real example of a real impact this institution made that moving forward to the future or not just looking at today. And this is where you get the tension between industrial policy. Do you invest lots and lots of money in what has already been invented, or do you invest in the future? And that's the big policy debate that you get.
I'm definitely going to come back to that in a moment. And in case you're not following the news, Paul has been on some lists for an Energy Department position should Trump win. So pay extra close attention.
This was his warm-up.
Yeah. The questions might be tougher next round, but just want to make sure folks are aware of that. I won't be asking Paul exactly what he thinks on this right this second, because I know he won't comment. But just to say that this is a very timely conversation. I want to lean into one of the core components of the Institute, and that is the global picture. And Shirley, I want to come back to you on this question. Most of us are probably aware that the global market for all clean energy technologies and also batteries is already dominated by China. How will the Institute's research consider that dynamic and the broader global competition?
Yep. So I think this is an excellent question I would hope to address. So first of all, I would like to readjust everybody's perspective a little bit. Today, lithium-ion batteries' world production capacity is 1 terawatt hour per year. Just for your information, it took humanity 150 years to reach lead-acid battery 1 terawatt hour, and took us 30 years to reach lithium-ion batteries 1 terawatt hour. And the US's peak power is 1.2 terawatt. So in fact, when we do the math, what is the total amount of batteries that is needed for enabling energy transition? That number from different sources is about 200 to 300 terawatt hour. Okay? Yeah, you can check the Tesla master plan. You can check some Rodian Group consulting reports, our own forecast. So 1 terawatt or 2 terawatt, including lead acid, it's going to take us 100 years to complete energy transition. So my main point here is that we will need to discover more terawatt hour energy storage solutions, and innovation is the only possibility to go forward. So yes, maybe for the lithium-ion batteries, that China is taking this leading position for the 2% job done. I think it's very important for the entire world to face this reality that energy transition, China will play a very important role, but the rest of the world, we all have to play equal amount of important roles, include India, include the Europe, include North America. So I think the time snapshot, a lot of the news media have represented is the 2022 time shot that China occupies 70% of the total world production and controls 90% of the supply chain. But if you reverse back 20 years ago, Japan controls 90% of the battery market, and they control almost all the supply chain. Because at the time, we are only at a couple hundred megawatt hour. So I think this time series data, that's where I would really, I'm so glad I'm in the Climate Institute, because there will be a lot of the expert in terms of how we incentivize scaling in the North America, in Europe. That is the question that only scientists alone will not be able to solve this challenge. So when I look at the China's dominance, I also want to remind everyone, China's grid is 80% coal-powered. And please remember, if you take anything back home today, battery is not renewable. We are not renewable. We are enabler for renewable energy sources. And that actually bear a lot of resemblance between the battery technology and the oil and the gas industry, because you need mining, refining, production, recycling. And the good news for battery recycling, everything is solid or liquid waste. So I can have 100% recycle success. And by the way, Argonne leads the nation's battery recycling center. So I hope that answers your question. I am not worried about the China dominance for this time slot, because for this time short, yes, they are leading, but it is a race, right? It's a global race, and in the end, all of us should race to the sustainable future. So I'm glad that China is taking the lead, but I'm also very confident through innovation that the North America and Europe will join this race and contribute our part about the battery production and manufacturing.
I want to thank you for that, Shirley. I want to come back to Paul on this question and then come back for a domestic look at the global challenge to you, Calvin, in a moment. But Paul, what's your response to Shirley's comments? I would love to hear what you had to say. And is it, what do you think it's okay that China may dominate in lithium-ion batteries if there could be other ways that other countries could lead? And do you think tariffs is a good way to pursue that type of policy?
Yeah, so once again, I'm going to sound like I ran the Office of Science, so I apologize for that. But it's a little bit like the Gretzky quote, which is, where's the puck going to be, not where it is today. If you go back just 20 years ago, the last generation, almost everything that we're deploying today did not exist 20 years ago. Stop and think about, was Tesla around 20 years ago? Not really. I think actually the answer is no. I did lots of wind and solar in my life. PV solar was not. It was actually a Berkeley project in 2009-10. PV solar was not even close to being economic. The lithium-ion battery was still a science experiment funded by the National Science Foundation and DOE. And so everything that we're deploying now, to a large degree, and drilling technologies, once again, unconventional drilling, not considered anything likely at the time. You add that all up together, that's what we're all doing today. And so it was invented within the last generation. And so if you go, and it's too long to get into, but if you look at the pipeline of what's coming up, whether it's multiple fusion opportunities or all these different battery chemistries, it swamps the opportunity, okay, that we accomplished already and what we're doing today. So if you add that all up together and you talk about the competition point, like, and I'm not saying that lithium-ion isn't important or the LFP battery isn't important, right? But the opportunity set to go where you want to head is so vast, right? Way better than what we've already accomplished, right? The US went from the largest energy importer in the world to the largest energy exporter this last year. We just accomplished that, right? Largest developer of technology and the largest capital markets in the world by far. So the raising of private capital for all this, we swamped the world. You add up all of that, yes, there's competition from overseas. Yes, there's competition from existing technologies. But once again, if you think about the future, right, we've done it, and the opportunity is even better. And I think the focus on the future is more important.
Calvin, let's turn to you, and would love your response to any of these comments about the global picture. But coming back to the domestic impact of, for example, China's dominance in clean energy, what China has done across the clean energy realm has been an incredible benefit to the United States. And can you talk about how you, as a company, have been able to implement some of these energy storage technologies and otherwise because it's been made so much cheaper due to what China has done?
To your point, China is playing a dominant role in all of this, has been stated. But here's the challenge. We operate a critical infrastructure. So when you have tensions on a global scale, the geopolitical, you have security issues. So when we have conversations with the administration on what can we do domestically to develop this ourselves, because of the security concerns we may have with the foreign nation, that's real. So as we go to implement some of this new technology, that is a question that we must answer, and therefore the time of implementation or even advancing that technology is lost. But what you do get is that a bar is set. By that bar being set, it encourages partnerships like with our national labs, with organizations such as MIT, University of Chicago, EPRI. All of those organizations then lean in with a concerted effort and focus because of the partnership with the federal government, private institutions, and academia to say we have to get better and we have to get quicker. And that efficiency is developed because of the pressure that's being put on us by China. So that's really where the end went, because I do not believe those public-private partnerships with government and academia would exist but for those other pressures being laid out. We have a hidden jewel in our national labs. And I would argue that most in this room, or at least in the country, do not know what's existing out there and the studies and the research happening in the national labs. They're setting the benchmark, but then how quickly can we get what's happening there and with the universities into commercial availability? That becomes the gap, but yet the opportunity. And if we do not have those partnerships, that lag will continue.
That's fascinating to hear you say that you have concerns with regards to security in terms of being dependent on foreign technologies, and that's prompted you to do some partnerships. That's really interesting, and it's a good segue to, I want to spend a minute, and Shirley, I want to turn this question to you. You know, partnerships we've heard it so many times over the course of this afternoon. They're the lifeblood of everything going on, particularly for a problem as omnipresent as climate change itself. So Shirley, what is your strategy for partnerships at the new institute? And would love to hear you comment on what Calvin said as well about the influence of security concerns on new partnerships.
Yeah, Kevin really presented the perfect point that I think that for any partnership in life, I think the starting point is always mutual respect. So I am someone who wear the hat as the faculty in Pritzker School of Molecular Engineering. I also wear the hat as a National Laboratory, Argonne National Lab person. And at the same time, I do have my own startup companies. And just like Paul, I had a little bit of the peek into the private sectors. I want to say that, once that we could set aside our differences a bit more, find the common ground. So, I mean, this threat, that security threat that put by the China dominance is actually one of those areas that drive us to come together to brainstorm about how we can do better together. So I want to say, hopefully next year's Climate Institute event, some of you will be invited to come to PME's Industrial Energy Transition Network space, where we will showcase how we build a physical space platform where we would really like to see university students and postdoc, Argonne scientists, and the private sector's people. We call it not internship, externship for the industry folks, that we want to use Climate Institute as a platform, actually provide the physical space and an infrastructure that allow this type of working together happen. So I certainly hope that's an invitation for next year, October, for having many of you come back to see how day to day we can actually operate, work together, collaborate together.
That's great. The final topic I want to bring up with our panelists is looking at something that's, of course, come up earlier in the afternoon about how the energy transition must not come at the expense of higher energy costs and stifling growth. So I want to turn this first question to you, Paul. How do you think about this issue in terms of, number one, let's ensure we move forward to clean energy in a way that keeps energy costs down? How does that inform your thinking in terms of research and science?
So some of you may not have gone to other energy conferences recently, but I was one that was sponsored by Eric Schmidt. That was a radically different, just 2 weeks ago, radically different set of conversations. That was about AI and energy, dramatic increases in energy needs. It's a good thing because we're talking about the economy. The amount of economic growth, 100 megawatt data center in our service territory, we got 100 of them, not all the average, but 100 megawatt data center is about a $5.5 billion investment. Okay, if you add up everything has to be put into that building, and we got about 4 gigs of that. So add up how much investment that's been made. It's like commercial and industrial rather than service economy, right? So we're making stuff in this country, and that's a good thing, right? And it's been a while since America has had this, commercial industrial where we need energy like China does or India does. This is a good thing, right? At the end of the day, it's good for the school system, the taxes. Believe me, if you're in Loudoun County, they got good schools now. So you got tremendous opportunity. In Virginia, we're supposed to double the amount of power generation in 10 years. So previously, it took about 30 to 40 years to build all the power plants that we have there. We need to double it in only 10. And Eric Schmidt and the people from OpenAI and AWS, this is all they're talking about right now, right? And so there's great opportunity, there's great upside for tax base, for economic growth, and so on. But you need to think about how are they, this is a little tough, but are they like free riders on the investment that the utility has made and the ratepayers, the customers have made for 20, 30, 40 years, depending on the asset type. And so there's a lot of debate in the industry about whether these new industries should take more than their average share. AEP, American Electric Power, has done that. At Dominion, we increased the transmission tariff rate to the data center customers and cut the rate to the residential customers. Okay, so actually the cost to the residential customers for at least a transmission component dropped for the residential customers. And I know you could probably comment to this with more detail than I can, but a lot of the utilities are thinking about how do we do that, and given that a lot of these new industrial customers do have a lot of profits that they're generating, and there's ways to think about that.
Yeah, Calvin, would love to bring you in on that. What's your response to that, and how can we keep electricity prices low as energy demand increases?
I missed a lot of what Paul was saying, because I was still stuck on what Shirley said. I had a perfect point, so I was really... Paul is exactly right. I mean, I agree with that. And what Paul goes down to, when you think about what he just said, it's all about the how. It's the rate design. Because going to how I started this conversation off, you can't do this if it's not done in an affordable and equitable way, because the noise and the pushback. But yet we have to do it. Going into not only security, but national security, we need those data centers stationed onshore. And I will give you something that, and I'll mess up the quote, so don't, if you know him, don't tell him I said this, Jensen Huang of NVIDIA, where he said, what we're not considering is that the data centers will get more efficient over time. So therefore, although we may be using X and Y today, tomorrow it will get to X, because they will become more efficient as they continue to learn. But it still goes into how we set it up today will drive it. And I got to give credit to those of you who live in Illinois. Illinois you talk about Virginia, is becoming a data center hub. Gil Quinones, CEO of ComEd, they're bringing about 6 gigawatts of data center load on, with another almost 10 gigawatts in the queue. People are coming to Illinois for a couple of reasons. One, the abundance of land. 2, the clean energy with all the nuclear plants. And 3, the rates that are being charged by ComEd. That is something that Illinois, you're just resource rich in that. And you're competing against the Virginias, and you're competing against the Texas. But that's the opportunity we have, but how we go about getting it is going to be very important. And then I would say the last piece of there is that our continued investment in technology to keep these issues at the forefront must be key. Sunny Elabua, who leads our chief strategy and sustainability efforts, is that we can't do it without continuing to grow. We have created our own model of where we're going to get net zero emissions within Exelon, but we know I have a clear line of sight to 80% of that. That last 20% is technology dependent. And I love the way Paul said it. We don't know what's coming, but we know it's coming, and we have to be ready to be early adopters of that new technology and scale it.
In our very final moments together, I want to do a quick lightning round, rapid fire, would you rather game. It'll go very quick, it'll be fun, no stress, won't be asking about Harris or Trump. Would you rather give up air conditioning or heating?
Ooh.
Air conditioning.
Oh, heating. We keep it at 59 at home.
Yeah. I would probably say heating.
Would you rather have perfect weather forever or cheap energy forever?
I run a utility. Perfect weather. Perfect weather, definitely. Yeah.
I would go with cheap energy. I lived in Hawaii, and for some reason I moved back.
Yeah, perfect weather for me. Because,
Thank you. Thank you.
And the final one, would you rather change the past or see the future?
Absolutely see the future. Please get ready for sodium batteries coming to your way.
I think I answered that about 5 times today.
See the future, yeah.
Yeah, see the future. See the future. Learn from the past and see the future.
On that note, thank you to our panelists
you.
for this great conversation.